Okay, thank you very much for everybody who joined our workshop. The workshop is recorded and we will put a recording on YouTube. This is, as you can see, the third, actually, the slide is incorrect. It is the third workshop on that is fully online. And the idea is to have the exchange of experience, catch up on what people are doing in serverless, and make it fun. So we have workshops ongoing for last 10 years. And serverless at the beginning was something that was a little bit maybe controversial. Why is it different from cloud? I think it is now fully accepted. We hope you all joined our Discord server, and there is the WOSCx3 channel and introductions channel. Use introductions to just introduce yourself, your research, or whatever else you want to say about what you are doing related to serverless, and use WOSCx3 channel to ask questions or general discussion related to this workshop. There is also a mailing list if you want to find out about future workshops or post about something that you are doing, organizing, or whatever else events. Please free to use that mailing list. And then we will have the regular workshop together with middleware at the end of this year. There is now call for papers, and the deadline for it, paper submissions, is in September. And of course, we will have the WOSCx3 next year, I hope. Serverless is also changing, right? So like function as a service, which was the main, almost the same as serverless way of doing actual serverless computing. Now we have all kinds of different ways that people are doing serverless or call things serverless. And of course, we have AI and all that happening. And it is interesting to see how this serverless experience or approach to serverless computation change or adapt to deal with those new ways of doing computing. And then in general, our goal of those workshops is also to bring some people from industry and academia together, sometimes more, sometimes less. But the idea is to always put those recordings online and advertise what we are doing in academia, so people in industry will know about it and hopefully can find you. Or, they will try your solutions, or industry will tell you about problems they have. This is just a general observation about the workshop. I will have that quack, quack sound, like duck animal quacking. If there is, it should be 5 minutes, not 10 minutes. And I think that's about it. Pedro, do you want to share or you want to say about a few words about the previous workshops? We are doing those online polls.
Yes. So we have a tradition in the last workshops to ask a couple of questions to the audience to see how you are feeling about the serverless computing. And the traditional questions were what are the main challenges in serverless computing? And we have a variety of questions. You see, the first one, people state was always there. Also, the second time we asked that. Productivity, latency, programming abstractions, and you see the different interest of the community. So we also asked in the second question about the challenges in serverless computing. What are the open challenges that have to be solved? And there were some overlapping in both questions. Today we have these two and three more for the panel. So you see here the future of serverless computing. This is a more open question. In some time it was like hybrid cloud continuum. In the other, we see more about single abstraction, computing as utility. But I think it's interesting feedback that we have from serverless experts, and we keep this tradition. So maybe now I share my screen and I start the poll for this.
Yes, go ahead, Pedro.
So, okay. So then let me go to here. So you should see now.
I can see your screen, yes.
You should see the screen and you have there, we are in the first question now. So
yes, so let's put the link to the menti.com, right?
Exactly.
This is online participation part. So use that link to put your answers to the question, and we should be able to see as your answers are sent, how they aggregate on the screen. Let me know, Pedro, when you have them, and I will also put them into Discord WOSCx3 channel.
So you cannot contribute, so you have to connect to menti.com and introduce this code, this 6030-1037. So we let some time for people to
Yeah, let's leave it
contribute
at least
here.
1 minute.
Yeah.
I am posting the link. Okay, I think we can see that sustainability is winning.
So we have 29 responses now. Alec, should we move to the next one?
Yeah, let's go to the next one. Yes.
Okay.
I think it's the same link. You can just refresh the page, or it should go directly to
So in fact, it moves directly when I advance page in your web browser.
So it seems that serverless need to be very sustainable.
Okay, interesting.
And AI is doing good too. So
Yeah. in both questions, sometimes it's common things like a state. This year is sustainability that it's interesting, and AI it was expected. So I think we have now even more answers, 31. So Alec, I also introduced here the 3 questions that we are going to ask the
Yes.
panel. So we
Go
can
ahead,
even
yes.
see how the audience reacts to these questions. So first question is related to our keynote speaker. I mean, he presented a very interesting paper about the definition of serverless that we know that in this community is somehow controversial. And an interesting concept that he proposed is that elasticity should not be part of the definition of serverless because cloud it already provided elasticity from the beginning. So it's not something that serverless should be stating because you can have like a serverless service that it's not elastic. So, but we will have like a discussion afterwards, and even Samuel that is here can help us about this. This is controversial and interesting for a panel.
Yeah, so we will have at the end of the workshop time to also talk about those questions, and then maybe based on the, what you saw in the workshop, your answers may change.
Exactly. So wait a little for people are still thinking. No, and we will put in the chat the link to the papers because some people, they may don't know. So if they don't know the paper, they can read a little about the motivation that Samuel is explaining in the paper. Maybe, Alex, should I move on?
Yes, let's go to the next one.
Okay. Second question there will be, I mean, recently some papers explain that, I mean, to maintain this scale to 0 and this pay-as-you-go model, in reality, the cloud providers, they have like super over provision cluster to be able to respond that rapidly. So it's this really too. I mean, are serverless services expensive because of this over provisioning?
And based on the previous answers, also impact on sustainability on or environment to keep all those hidden servers to keep serverless going.
Yeah. Even I was in the Sesame workshop, another serverless workshop that appeared recently in Eurosys, and I think the chair that they even measured what was the proportion of our provisioning that should be maintained. I don't know if it's a magic number or if it's true, but they really provided some number in their paper about the over provisioning in memory and compute that a fast should provide. And of course, we are speculating. I mean, maybe, I mean, we only have insiders here like Alec that could tell us the truth, but the rest of us from academy, we don't know about
I
managing
can
this
tell you for
service.
sure, people really care about sustainability, and there are several projects like Kepler that want to make it much easier to understand cost of running Kubernetes and systems like that. And I mean cost to environment, like energy usage and so on.
Okay. Nice. Maybe we move on.
Yes.
So last question. This is another word cloud. So what novel serverless services would you like to see in the next year? So just blue sky thinking. I mean, think about really cool things that you would like to see by the public cloud providers.
So it seems the new serverless is sky computing, right?
Yeah, many of the ideas are related to the challenges of serverless computing that they mentioned, like a stateful, like I see also here, communication, X-fast. I don't know what it's X-fast, but it's interesting to analyze. So I think, Alec, that we have 21 responses and they were creative. So we will, of course, share all these ideas and plots and with the community in Slack and in Twitter. Maybe we'll give 2 minutes because I still see contributions from some people.
Yes, and just one like future thing, not Slack, but Discord, but yes.
Discord, exactly, yeah.
Slack was in the past, but with their business model, we cannot afford free Slack. That
Yeah. So I think we can finish here, Alec. I can stop sharing and then you continue with the keynote with Samuel.
yes. So Samuel, please share your screen, and we will then start with the keynote. You have our undivided attention. There will be time for the questions at the end of your keynote. Aim for like 30 minutes. And also people, if you have questions in the session or afterwards, make sure to raise your hand. There is an option in Zoom to raise your hand. So, we know that you are asking question. Of course, you can type it in Zoom chat or in Discord chat and we will monitor. But if you raise your hand in Zoom, then just we bring you up and ask your question live. That's the point of that live workshop. Samuel, go ahead.
Thank you very much. Thank you very much for inviting me also. In fact, some of you I see here in the audience also attended CC Grit. So you should know about this keynote already. I mean, it's not realistic to produce a new topic in just a couple of weeks. So yeah, I'm going to reuse basically the topic. So Jesse, sorry, you're going to be bored, but maybe you can do something other, process some emails in the background. But anyway, it's mostly the same keynote I gave at CC Grit, basically. And I have slightly updated and changed a little bit some things. I like very much the questions you raised in the beginning. This is the perfect setting for the keynote, basically. I am very happy about the controversial reaction to the first question, basically you gave, which shows that there is a need for some discussion and it's perfect setting. So let's start. The topic of this keynote is going to be about the term serverless computing itself as a paradigm, the evolution, how it evolved, and also how it differs from other cloud service models. I want to put the focus on this because I saw the reaction to the first question you gave was controversial. I was actually initially thinking maybe I should skip this and maybe focus on the second part about selected topics in serverless computing. But after this reaction, I think we should do the first part in detail. And basically, this third point, selected topics in serverless computing, includes several selected kind of papers that we have published. And I have put the slides, not all of them are going to be presented here, so you can follow if you like offline. And I would like to start with the first topic, and the term itself, serverless, is quite old. And you can see here a paper that was published in 95 with one of the co-authors, David Patterson. We'll hear about him later, so that's why I want to mention this. And here he talks about the serverless system utilizes workstations cooperating as peers to provide all file system services. So it's a little bit more like a peer-to-peer system, but they use the word serverless for it. So of course, a different interpretation than what we have in our community nowadays. But it has been used. It's not popular. It was not popular then. It became popular after AWS Lambda, as you all know, which was released in November 2014. And this was the major kind of breakthrough. And it was mostly about function as a service as defined by AWS. You know this definition. I'm not going to spend much time, but Amazon promoted it and it evolved very quickly. So there was a kind of buzzword effect. All of a sudden, a lot of people were interested in this topic and it increased in popularity. And there was a paper written by different members at Spec Research, at the Spec Research group, on serverless applications, why, when, how. And it found out that most of the motivation for serverless computing is to save costs, but also the built-in scalability and on no operations aspects. So this is interesting. So as always, when a new kind of buzzword, if you like, emerges, there is a lot of use of that in industry and academia, and some controversial viewpoints might emerge. And we discovered this at a seminar we organized in 2021, unfortunately during the COVID pandemic. Some of you attended this seminar, so you're familiar. And it was with 50 researchers from the cloud computing, distributed system software engineering community, including also performance engineering experts. And this workshop was quite well attended, a lot of discussions. And in these discussions, we came up with some topics and kind of challenges that need to be addressed in the serverless computing community. And as you can see here, quite prominently, C3, it was about agreeing on a serverless definition and making it operational. So the reason for this was we spoke at this workshop and we discovered that even though we all think that it's quite clear what we mean by serverless computing, when we start discussing it, we see that it contradicts and we have different viewpoints, some of them more broad, others more narrow, and often quite different, actually, not just a matter of formulation, but also a matter of essence of the topic. And there were even some people that were saying basically, it is nothing new, it's just a new buzzword, right? So interesting observation. We decided to follow up on this. And unfortunately, back then, we did not have ChatGPT. It was an unfortunate situation. We could have asked ChatGPT and maybe it would have saved us some time. But after, a few years now that we have ChatGPT, I just thought maybe I should experiment and see if we would have saved time by asking ChatGPT. So basically the main question I wanted to discover is serverless computing really new, or is it just another word for some things that we already know, another permutation, if you like, another kind of bottle shape, but the same wine inside? And I asked ChatGPT and there was an answer. As we know, ChatGPT is not very popular for being concise, in terms of answers. So it was quite the opposite of concise. It gave us a lot of information, Not intended to read all of this, but one thing caught my attention in this answer. If you look in the beginning, it says, while some aspects of serverless may draw from previous concepts like platform as a service and function as a service, it introduces several distinctive features and benefits. I like this. This catches my attention, but what caught my attention, some aspects draw from previous concepts like platform as a service and function as a service. So function as a service is considered from the perspective of ChatGPT as a previous concept, and serverless computing is some kind of new concept with some distinctive features and benefits listed here. I did not spend much time reading this. I mean, I read it, but I was not satisfied. So I asked ChatGPT, could you please be more concise and to the point to save me time in digesting all this information? So asking ChatGPT, it's always very polite. That's a good feature. So it immediately gave me a more compact answer, which was very similar, just removing some details. And it claimed basically serverless is really something new. It's not just rebranding of existing concepts, packaging them in another kind of mix and new term, but it's really something new. So good, it was at least a clear answer. However, looking at these things here, pay-per-use billing, automated scalability, they sound to me a little bit, what shall I say, quite known actually. It's not really that I'm surprised to see these things. So I was thinking, how are these different from what we have read from early cloud platforms like Google App Engine, for example? We have seen all sorts of different cloud platforms, and some of them could have all of these concepts or parts of them. So are they really new? And I asked this question, and there was this time a more compact answer. Again, very polite, you're correct. These are underlying, concepts, and they're not completely new, and pay-per-use billing and abstraction of infrastructure have roots in earlier cloud platforms, blah, blah, blah. However, serverless computing has some new features like event-driven architecture and microservice composition. Wow, so it's like these are the new features, are the event-driven architecture and microservice composition. It seems like this is the distinct new things. It's not about the pay-per-use billing or abstraction of the infrastructure. They're just, roots in the earlier infrastructure. And this struck my attention a little bit because if we look at event-driven architecture, and the definition of this kind of platform, it's in the function as a service platform definition that we just showed a few slides back, that the event-driven architecture is more or less assumed there. And the microservices composition is quite a classical approach. So I was wondering, on the one hand, ChatGPT mentioned that function as a service is a kind of previous concept, right? Previous concept in the first answer. On the other hand, it refers to some of its main characterizing features as the new thing in serverless computing. So it's like serverless computing is new, but the new thing is something old. So it's like running in circles. And I was not satisfied, so I asked, and there is this kind of, seems like an approach, if you cannot convince them, confuse them. So there is plenty of answers here, but they were running in circles. I'll come back to it later. I want to stop at this point. I was not satisfied with these answers, basically, because they could not convince me what exactly is the essence of serverless computing. So obviously, we have not missed much by not having ChatGPT back at the workshop, at the seminar. And after the seminar, there was an effort started by a subgroup of people that attended. And we wanted to basically come up with some understanding that we agree on as a community. And there were many of definitions that we studied. And here I summarize 6 of these definitions on serverless computing. They come from the academic community. And you see here, they have quite a lot of citations. These are quite visible papers. They talk about the term serverless computing and define it in a way directly or indirectly. And these 6 definitions, I'm not going to now go through the text. It's mostly basically to first give you the overview, and then I will dissect them in parts to digest basically this information. But these 6 definitions you see here with a lot of visibility, they have some kind of common aspects they cover that are put in different colors here. For example, no ops, no operations, function as a service, pay as you go, auto-scaling, elasticity, backend as a service, or event-driven architecture. So you see some of those colors are everywhere, like no ops and function as a service. Others are not everywhere. Like if you look at event-driven architecture, it's only mentioned twice in 2 different definitions. In the others, it's not even mentioned. So interestingly, what ChatGPT was claiming to be the main distinctive characteristic is not even mentioned in most of the definitions in the academic community. Only in 2 of them we see event-driven architecture mentioned. Backend as a service mentioned a couple of times, and autoscaling 4 times from the 6. Now let's digest this because it's a lot of text. No ops. So let's start with no ops. The 6 definitions each say something about no ops. And this is basically extracted from the definitions, what they say. The developer does not worry about operational aspects, blah, blah, blah. However, if you read some of these statements here, need not concern themselves with provisioning or operating servers. I mean, I could have copied this from some marketing material on cloud computing 15 years ago. It would say exactly the same thing. Need not concern themselves with provisioning operating servers. We virtualize everything, so we manage it for you, and you can obtain infrastructure on demand, and you're not provisioning or operating the servers. So it looks very, very familiar, this kind of wording, although we know what the intention is. The wording that is used is very, very kind of familiar to us, or sounds familiar, which might make the impression that we are speaking very much about popular things that we already know. So this was one observation. And if you look at the NIST definition of platform as a service, you will notice here the overlap. The consumer does not manage or control the underlying cloud infrastructure, including network, servers, operating systems, and storage. So in my opinion, this sounds very similar to what we have in these definitions here. The platform as a service definition did not exclude this kind of platform. It's just possible. Maybe not everyone was doing it, but it was definitely part of the definition. So this is not really something completely new, at least the way it is formulated here. Pay-as-you-go, the second property, is mentioned in most, but is missing in the second definition. And here it's mostly that the definitions speak about pay-as-you-go or build only for what is running and such formulations. However, if you look at the popular Berkeley article on cloud computing from David Patterson's group from 2009, they also speak of pay-as-you-go, and they define it also in a similar way. Maybe, okay, they don't speak of fine granularity, right? Maybe this is the point here we have in the definition. Some of them mention granularly, right? Fine granularities, others don't. But some of them mention fine granular, so maybe this is the thing, but it's definitely the term pay-as-you-go. It's quite old. Also pay-per-use, it has been used all over, so it's hard to understand exactly the formulations, how they differentiate it. Maybe some of them are a little bit better, like for example, this one, speaking about reservation-based explicitly, makes it a little bit more clear what the intention is, but others are quite fuzzy to understand. Anyway, is it just function as a service? Is it more? So as you see, all of them include function as a service. Some of them mention backend as a service, like number 5. Others mention something more that is called standard library. They don't call it backend as a service. So they say it's not only function as a service, it's more than function as a service, but most of them do limit more or less to function as a service. They don't mention anything more than function as a service. So it's like the question, do we really need another name? If it's the same as function as a service, then just keep the name. And why do we need serverless computing as a name, right? So that's also an interesting observation about the scope. Event-driven architecture, surprisingly, as I said, contrary to what ChatGPT was claiming, only mentioned twice in 2 definitions here, where they speak of event-driven or event-based programming. And now it becomes exciting, autoscaling, elasticity. Now, they do mention autoscaling and elasticity, as you see here, apart from number 2 and number 4, they do not mention it. Others mention it. And they speak of scaling from 0 to infinity, automatic, rapid, unlimited scaling, and so forth. And this is what also caught my attention. If you look at the NIST definition of cloud computing, you might wonder, I mean, it's almost like copy-paste. Some of these words are very, very similar, like rapid, elasticity here mentioned, or capabilities provisioned and released, in some cases automatically, so it's not excluded that it's automatically the NIST definition of cloud computing does not say it has to be manual, right? In some cases, it might be also automatic. They rapidly scale outward and inward in both directions with demand, right? In unlimited manner. So many of these keywords are almost one-to-one matching what we see in the definitions that I mentioned, the highly cited definitions of serverless computing. So again, from my perspective, at least the way formulations are currently made, it is not very clear how serverless computing differs from classical cloud computing, which obviously has similar goals. Maybe some of them were not realized immediately, but it had similar goals from the very, very beginning. Now, elasticity in cloud computing is also a topic we researched on some time ago. If some of you maybe have seen this article on elasticity in cloud computing, it's at ICAC in 2013. And there we defined elasticity in cloud computing, right? There was not any serverless computing back then in terms of, AWS Lambda. So the degree to which a system is able to adapt to workload changes by provisioning and deprovisioning resources in an autonomic manner such that at each point of time, resources match current demand as closely as possible. So this has become a highly cited paper on the topic of elasticity. And it's interesting because if you look at the way we looked at it, we interpreted elasticity basically as looking at the workload in terms of, for example, requests per second or similar kind of metrics. And if the workload varies over time, like in this graph there, we consider the resource demand, which is the minimum amount of resources required to fulfill the service level objectives, which might be response time related. So looking at the resource demand curve, which is the red curve, we might then compare it with the supply curve, the blue curve, which shows us the actual provisioned resources by the cloud platform. And then we see that at some points of time, there were more resources provisioned than required, minimum, the needed, so to say. These are over provisioning times, and at some points of time, there were less, and these were under provisioning times. Right, so this is our understanding of elasticity, also matching the definition that we published in 2013 before AWS Lambda was on the market. And if you look at this definition and then match it against the wording in these definitions of serverless computing, at the top, you might be struck. Basically, it's almost one-to-one. Basically, it's not really essentially something different that they're speaking about in these definitions. So the question is it really new? Maybe it was not realized, but is it really something new, serverless computing? Or is it, that we just put another word out? And that's what motivated us to write this article on serverless computing, what it is and what it is not. As you see, it's similar title to the one about elasticity because the situation was similar. There was a confusion we wanted to clarify, and we wrote the article on elasticity. So we wrote this article on serverless computing based on the discussions at the seminar in Dagstuhl, summarizing what our findings were. And the initial kind of, so the final definition that we published in this article is given here, and it was based on a very, very similar, almost identical definition that was published in the seminar report. I'm not going to talk about it for lack of time, but here you see basically the one that we refined, a little bit after the seminar and published in this article. So we tried to pick here a formulation that on the one hand covers the current state of things, so it does not directly contradict today's notion and interpretation of serverless computing. On the other hand, accommodates the future developments that we expect, basically. And this is really a challenge here to be, open for the future, but also covering the current limited kind of serverless computing incarnations, right? So we came up with this formulation. It's about a class of cloud computing platforms. So it's not really that we speak about something else. We are in cloud computing platforms, and they allow us to develop, deploy, and run applications or components. There are very important parts, by the way, because in most of the serverless applications, you will see both serverless components and non-serverless components in the same application. So it's not about definitely an end-to-end platform. It might be only the component that is serverless in the cloud. Without allocating and managing virtualized servers, again, a very important word here, not just servers, virtualized servers, because servers and their kind of management in terms of hardware. This is something from the beginning of cloud computing. And here we want to also get rid of all management related to virtualization and virtualized resources, or in other words, all concerns, all operational aspects as formulated here, being concerned about other operational aspects. So the responsibility of such aspects, for example, fault tolerance and elastic scaling of computing, storage, and communication resources, these responsibilities are offloaded to the cloud provider. So again, here we use elasticity as part of the definition, but only as an example. And why? Because in our opinion, elasticity is just a detailed technical aspect, just like fault tolerance is, or other management aspects about operational concerns. And in our opinion, serverless computing is about abstracting these technical aspects. So these are just two examples, and elasticity is one such example. You know, taking care, putting the responsibility completely in the hands of the provider, so to say, instead of sharing this responsibility with the user. And since elasticity is also something that from the user perspective, given, you know, pay-per-use billing, which is the second aspect, is not really making a difference. I'm going to explain this in a second, but let's first notice that it has, according to our definition, two aspects: no ops and utilization-based billing. Now, the second one we called utilization-based billing to not use the original pay-per-use wording, which is already used in the cloud context. And we defined utilization-based billing as really charging in fine granularity in proportion to the resources actually consumed from the cloud infrastructure, as opposed to reserved resources and similar. Now, notice one thing. If you assume utilization-based billing, right? Let's assume you have utilization-based billing and you're a user of a cloud platform. You're a user and you have utilization-based billing, which tells you the cloud provider can only charge you for the actual consumption of resources during the running of your code. No other charging, right? So my question then is, does the user, under this assumption, care if the cloud provider is elastically scaling, if it's not elastically scaling, if it has a huge infrastructure that maybe does not need to scale, maybe it's so powerful it never needs to elastically scale. It always has enough, basically. Does the user care? No, it doesn't care, because the user only pays for the consumed resources. So even if the resources are huge and they are over-provisioned, let's say it's hugely over-provisioned, they are not utilized. If the user is not paying for them, he's not even interested if it's elastic or not elastic. The important thing is that the operational service level agreement should be satisfied. How they are satisfied? By over-provisioning, by nice auto-scaling or whatever. This is all detail that is completely abstracted behind the abstraction here, no operations. And in that sense, and that's the reason we believe that, you know, putting, you know, elasticity prominently here has two issues. One, it's nothing new, as we saw in the previous definitions. And second, it in a way contradicts the vision that under utilization-based billing, actually, the user does not care about these aspects. He only cares about service level agreements. How they are enforced by over-provisioning or other means is left to the provider. Of course, the provider now has much more pressure, because in the past, he could just say, I don't care if the utilization is low, it's a problem of the user, I charge him for the poorly utilized servers. Now the provider cannot say this anymore. So there is pressure on the cloud provider side to actually do auto-scaling, to do elastic scaling, because if they don't do it, they have waste of resources for which now they pay, not the user. And that's the difference. In the past, the user paid, now they pay. So this is the sense. We did define an analogy to compare these to moving homes, where basically we compare traditional moving companies or moving it yourself kind of approach, where you're responsible for everything: packaging, delivery, operations, legal, financial, and so forth aspects. Traditional moving company would take some of those aspects and be responsible for them. And a kind of modern kind of mover would take care of all of these aspects and abstract them for you, so you don't have to care about them. You just say, this is the address, please, these are the keys, please let me know when you're finished. And I enter the house and everything is completely as I expect. So it's about automation, it's about service, and you can compare these modern movers like serverless computing, right? And traditional movers like cloud computing, which only take care of some aspects, but not of all aspects, versus moving it yourself, kind of pre-cloud computing, self-hosted infrastructures and self-managed infrastructures, on-premise infrastructures. So this is our analogy that we put out, and we basically claim in our article that serverless captures in a way a shift of focus in cloud computing. Basically, most of the aspects in serverless computing were not like prohibited, right? They were compatible with the original cloud vision. However, they were not prioritized. People did not realize them, right? And now we have kind of a shift of focus in terms of prioritizing these things that in the past were theoretically possible, but were not done. And the prioritization leads to some shift of focus from low-level virtual machine interfaces to high-level interfaces, shift of focus from explicit allocation to automatic resource allocation, shift of focus from cloud users responsible to offloading these responsibilities, from coarse-grained to fine-grained multiplexing resource sharing, and to real utilization-based pay-per-use as opposed to reservation-based cost models, from coarse-grained to fine-grained resource usage accounting, and from having less control, from having more control on the user side to having less control on the user side. And this, in our opinion, is what serverless computing as a term captures, is this shift of focus in the cloud space from one class of platforms, mostly infrastructure as a service, which was the typical, most classical platform that was on the market, to platforms like now in serverless computing, like function as a service and similar, that have all of these or some of these prioritize. We also claim that serverless is not a black and white kind of property, that you're completely serverless, you're completely not serverless. Basically, it's a property where you could argue that in one aspect you might be more serverless, in other aspects you might be less serverless. It depends really on the platform. And normally it's a mix of implementing these aspects to different levels. So the evolution of cloud service models is sketched in this diagram. And since I'm running out of time, I will go a little bit quicker here. But you see here, we started very early in the 1960s. And from here at the top, you see serverless computing appearing, where in addition to function as a service and backend as a service models, also container as a service model is mentioned. You see also that many of the concepts like resource sharing, multi-tenancy, but also resource federation were quite old, and these were before even cloud computing emerged. Pay-as-you-go in cloud computing, on-demand resource provisioning, elasticity in cloud computing, but then, you know, the fine granular utilization-based billing and no ops in terms of abstraction of the operations, it's in serverless computing. So this is one way to basically summarize the developments. I'm going to skip these slides. They show a little bit the differentiation from the different types of platforms. The benefits of serverless computing is mostly about cost efficiency, but also about the less concerns in terms of operational tasks, which make it much easier to develop complex applications without having to take care of those issues. Now, I mentioned I did not stop the discussion with ChatGPT, and I continued actually discussing, asking questions again and again. And after 1 hour, you know, ChatGPT, you know, obviously has learned something from discussion. And this is something really remarkable, that after 1 hour discussion, I repeated the question in the same session, basically the question I started with. And notice what an answer came out. First of all, much more concise. I was really happy about it. Obviously, ChatGPT learned that I'm not very happy about long answers, so it concise answer. And then serverless computing is akin to a new blend crafted from familiar grapes. It's about abstracting away server management entirely. The word entirely, by the way, quite important, right? So this sounds much, much more better, I would say, much better than the original answer I got. And obviously, when you discuss with ChatGPT, it learns from the discussion and it improves, obviously, which is really remarkable. In the rest of the slides, which I'm going to skip for lack of time, I only have 2 minutes according to my calculation. Please correct me if I'm wrong. in the last couple of minutes, I want to mention these are selected topics. Resource sizing in function as a service is a paper we wrote, which also has been quite successful. And here it's about the problem how to configure the size of serverless functions. And we provide a machine learning based approach to predict the optimal size of serverless functions without having, experimented with all possible configurations. So this is quite interesting work. I do have slides included that show you the details. The second one here I want to mention is a paper about auto-scaling from the practitioner perspective. We worked with a company, Datev, here, where we had specific feedback from industry, and they were saying, look, you have a lot of approaches in academia, but in reality, we run against these problems, and these are problems in practice. And that's why most of the approaches from academia did not make it into reality. And this paper discusses this issue. And we also have a new kind of line of research that is considering decentralized autoscaling, where we try to completely distribute the control logic for autoscaling. This is something we published also as CC Grid last year, together with another paper that was on container start times. I want to mention very briefly. It's of course a topic related to autoscaling, because if you start containers very quickly and efficiently, you can autoscale more accurately, right? Especially with functions that you put in containers. So container start times is an important topic, and this is a paper we wrote about how to model and predict container start times without looking inside the details of what is in the container. A lot of these works are in the context of Spec Research Group, where we have these different subgroups here, and we collaborate. So the papers I showed you are mostly immerged in this context here of the Spec Research Group. So if you're interested, you're more than welcome to join us there if you're interested to collaborate on such topics. To summarize, serverless computing, in our opinion, is a high-level, broadly applicable paradigm, which could be applied to many levels. And it's also a shift of focus in cloud computing from one type of platforms, the classical infrastructure as a service kind of virtualization-based platforms, to new kind of platforms that, were not prioritized previously, that provide two main properties, no-ops and utilization-based billing. And we do believe that there are many challenges still to be addressed, and one of them is the resource sizing and autoscaling that in theory are all solved in theory, but in practice, there are many issues to be still addressed. So this is it. Thank you very much for your attention, and I look forward to questions from the audience.
Yeah, so if you have a question, please raise your hand. There is an option on bottom of your Zoom. There should be something like raise your hand. Okay. I think Trevor asked the question, and I have a question also asked in Discord. So let me start with my question, which goes back to that elasticity. Is it part of the definition or not? I think in practical terms, yes, because if you pay for something, you really want to know that what you are getting is like quality, cost, and all those metrics are met. So if that service has not good elasticity, for example, I could have non-elastic service and then claim it is serverless. That probably is not what users expect. If it only runs to some capacity and then it stops running, that probably I would not call it serverless, at least in the way that people think about it. So that is my question. And after that, Jesse, go ahead with your question. Samuel, what do you think about it?
Yeah. So basically, capacity in this planet is going to be always limited. We agree on this, right? So let's imagine that I'm a user and I have a platform, a serverless platform, and the platform provides me a service level agreement and says, I'm going to ensure that your response time of your service is going to be never exceeding, let's say, or on average, not exceeding, let's say, 2 seconds. I personally, as a user, would be satisfied. And I would not be interested to know how exactly, you know, elasticity is implemented or not implemented. So theoretically, let's say theoretically, the provider might decide, I throw a lot of hardware there and I satisfy my service level agreement and the user is happy about it, right? Theoretically, right? It's one possible approach. Of course, it will be expensive for the provider. So that's something probably the providers would not do. However, from the perspective of the user, if my service level agreement is satisfied, I would be happy to pay for whatever, you know, I only pay for the consumed resources, right? So if resources are wasted because the cloud provider is not clever enough to do elasticity, right? If he wastes resources, it's his problem, right? It's not my problem. I pay only for the actual consumed resources. If there is idle resources in the game, the cloud provider is now responsible. That's the difference. And so my answer to the question is, first of all, if you look at this perspective, you know, the user perspective, elasticity is just one technical aspect, just like fault tolerance, just like logging, like monitoring, like all sorts of other aspects, security and such things that in serverless computing are abstracted, right? They are abstracted. I'm not responsible anymore for these aspects. So that's one part of the answer. And the second part of the answer is, if we put, you know, elasticity explicitly as a kind of major distinguishing factor in serverless computing, we have the issue, as I said to you, we have to forget a little bit about the past. Basically, we have to delete some memory. And that's my problem, because if you look at how many papers they were written and they were speaking exactly of the same thing, and not a single time serverless computing was mentioned. I just showed you our paper, but there were many other papers, right? Then you have a problem basically that you are now introducing, you know, this property as a major distinguishing characteristic, but in the past, others were speaking exactly of this property and not mentioning serverless and speaking about cloud. So this is my basically twofold answer, but I agree with you to the point that it is an important property, and you, from a practical perspective, it will be addressed in most of the platforms, obviously.
Okay. Thank you. Jesse, you had your hand raised first. Go ahead.
All right, thanks. Thanks, Sam, for a very nice keynote. It's true that I was also there at CC Grid, but I think maybe similar to a good book, it's good to see the same, get the same, consume the same ideas multiple times and let it simmer for a bit. My question, okay, let's pick one, but a question I have is in the previous, answering the previous question, you mentioned a serverless platform and a hypothetical serverless platform. What would be a killer serverless platform or application that we would want to, that basically, well, solves the problem or shows that this is really the paradigm that achieves the goal that we're envisioning here, and why don't we have it yet?
So if you look at David Paterson's new article, is one of the articles that I cite also here with one of the definitions, actually one of the better definitions. In that article, they explicitly distinguish between general purpose serverless computing and domain specific, so to say, platforms, right? And in my opinion, it's still a question to be answered if a kind of general purpose serverless platform that provides really like a virtual computer that you could program against, providing complete abstraction, a complete programming, end-to-end programming model, right? Today we don't have it. I mean, function as a service is quite popular, but it's just one bit, and normally you have other things, and you end up using X other non-serverless parts in your end-to-end application, right? So we don't have a full-blown end-to-end platform where you could build completely without any kind of technical concerns, end-to-end application to be executed in the serverless world. We do not have this general purpose platform, but however, we have specialized platforms for different domains, focusing on different domains. And in my opinion, it's a big question if this general purpose platform will emerge at one point, a kind of general purpose programming model, end-to-end programming model for the serverless cloud, without all of these limitations we have today in function as a service and so forth. If this would happen, it would be a major game changer, I would say. Other than that, what I think is a major game changer, which we also discussed after CC Grid, if you remember, and I want to stress it also here. Other than that, I think it's a major game changer that the utilization billing is enforced in serverless computing. Why? Because even though it's more like a business property about pricing, about charging, right? You might think, oh, this is non-technical stuff. It makes a huge difference. Why? Because I explained, if the cloud provider is forced to pay for all unused resources, then he's obviously pushed and pressured to improve efficiency. There is automatic link to the money, right? And the money drives a lot of things here. The cloud provider has to pay for unused resources. He's now pushed to not let them being unused. So he's pushed to do elasticity. He's pushed to do auto-scaling. Otherwise, it will be very expensive for the cloud provider. And I think this is a major change in terms of sustainability, because serverless computing with this new kind of utilization-based billing is in a way forcing cloud computing to become what it originally wanted to be, to drive efficiency to a huge extreme, economies of scale, to avoid wastage of resources by resource sharing and pooling, right? This was the original vision. In reality, what we wanted to have. What happened in the first phase was we got, infrastructure as a service, reservation-based models where people, reserved servers that were not used. So they were idle. So this is not really the original vision. And I think this is the major game changer here, as I said, efficiency, sustainability, and also with a question mark, if we get a general purpose platform, this would be a game changer.
Many thanks for the answer.
Thank you.
Hi, Pedro, you have your hand raised?
Yeah, I will be brief, and Samuel, you should be brief also, because we don't have many times. So,
okay, sure.
Last time. So no, my comment here about elasticity is that obviously when people think about serverless, most people think about function as a service. And I think that maybe function as a service like Amazon Lambda was like elasticity or burstability on steroids. So no other service in the cloud could do like Lambda could do, like launching like this because the EC2 autoscaler for web applications was not that elastic, no. So it's people think that elasticity is linked to servers, maybe because Lambda is like the paradigm for elasticity, because you didn't have that before in the cloud. So what do you think about that? It's maybe because of that all of us, when we think in function as a service or serverless, elasticity comes to our mind, even if it's a previous concept from cloud. That I agree.
Yeah, you're completely right. This is a very good observation, Pedro. And I want to say basically that from the experience of the last 20 years or 15, 20 years, we see that if you look at literature, we wanted to have elasticity all the time. We wanted. In practice, it turned out to be tricky. And in practice, what the cloud provider decided, oh, it's hard to provide it, so I leave responsibility to the user. So, I provide some basic trigger kind of functionality, but the user has to ensure. And, in the end, we ended up prioritizing, platforms that only address this property semi-automatically, so to say, right? So function as a service came, and you're completely right. Something changed. And what changed? Elasticity now flies all of a sudden. It flies. Why does it fly? Well, very obvious. Because of three assumptions that function as a service makes. Assumption number one, event-driven. Assumption number two, small. Assumption number three, bingo, stateless. These three things taken together make it easy to do elasticity. That's why elasticity worked in function as a service, because if you limit the scope to stateless, small functions that are triggered based on events, it's much more easy to do elasticity. As soon as you introduce state, as soon as you introduce bigger functions, things become hard. Also, with respect to pay-as-you-go, right? Imagine the function is running and you're, paying, for the time consumption. The user might be shocked, by the bill. So if it's a small thing, it's much easier. You just reset it at one point, timeout, no surprises. So sorry for being a little bit longer, but this is basically my answer. You're completely right. Function as a service made elasticity prominent by making it pragmatically work for this very limited setting.
Thanks a lot.
Okay, if there are no more questions, we will have a short break, 5 minutes maybe, and then we will continue with the first session with 4 talks. And of course, if you have additional questions you wanted to ask, well, ask them in Discord. That's the, good place for it. And also we will have time at the end of the workshop if you have some thoughts about elasticity or anything else. So let's get back in about 6 minutes and 15 minutes after hour.
Thank you.
And if you are speaker for the next session, just say in the chat, Zoom chat, that everything is good. We all tested screen sharing and so on, so I think we are all ready, but just in case.
So Alec and Pedro, I'm going to leave for about half an hour and we'll be back online for the remaining workshop, just for your information in case of, for the panel and questions. Thank you.
Great. Thank you, Samuel. It was a really great keynote.
Sure. It's a pleasure. Thank you.